Hello. In this video, we're going to talk about Scratch, one of the most influential programming platforms ever designed and built for children and beginners. Scratch has been around for nearly 2 decades, and during this time, it has changed the way many people are introduced to computer science. This video has 3 main goals. First, to explore how Scratch came to be and what purpose it was originally created for. Second, to understand how Scratch has evolved over time and how widely it is being used today. And third, to provide an honest evaluation of whether Scratch is still considered a valuable tool in programming education or not. By the end of this video, you'll be able to decide in which situation Scratch is the best choice, and when it might be time to move beyond it. Let's dive into the first question. Why was Scratch created and developed? To answer this, we need to go back to the early 2000s. During that time, if someone wanted to learn programming, they had to start with text-based languages like Java and C++, and later Python. Although these languages were powerful, they posed a lot of challenges for beginners. Constant syntax errors, abstract concepts like loops and conditionals that were difficult to imagine, and the lack of immediate creative feedback were just some of the obstacles that beginners, especially children, struggled with. As a result, many students became discouraged and gave up before they even understood what programming truly was. Researchers at the MIT Media Lab viewed this not as a technical problem, but as an educational one. They believed programming should have certain characteristics. It should be creative, play-based, and accessible to everyone. Now, the beginning of Scratch. Scratch was officially launched in 2007 by the Lifelong Kindergarten Group at the MIT Media Lab. The key figure behind Scratch is Mitchell Resnick, a professor of learning research.
I think with Scratch, it's possible for everyone, literally everyone, to create their own interactive stories and games and animations and simulations, and then share their creation with the world.
His core belief was simple but powerful. Children learn best when they are actively creating things that are meaningful to them. Scratch was designed not just to teach coding, but to promote creative thinking, systematic problem solving, collaboration, and sharing. The idea was to treat programming as a new kind of literacy similar to reading and writing. But what makes Scratch different? The most important decision in Scratch's design was the use of block-based programming. Instead of typing lines of code, students drag and snap colorful blocks together, and in this way, the program takes shape. With this approach, syntax errors are eliminated. The program structure is displayed visually, and the focus shifts from typing to understanding the logic behind the program. With Scratch, you can create games, build interactive stories, produce animations, and run simulations. From the very beginning, learners start expressing their ideas creatively and personally, and that's what makes Scratch so appealing for beginners. Let's take a look at the global scale of Scratch usage. The numbers will amaze you. Scratch is not a limited or local tool. It's a global platform. Today, more than 100 million registered users have signed up on Scratch. Hundreds of millions of projects have been created using Scratch. It is used in every country around the world. Scratch supports over 70 different languages, and it has been translated into all of them. Scratch is used in a wide range of settings: elementary and middle schools, clubs, coding classes, and even in some national education systems. For many children, Scratch is their very first encounter with computer science. But let's take a closer look at Scratch's strengths. What are the other reasons behind Scratch's success? What factors led to its even greater achievements? We can categorize the main reasons like this: an extremely easy entry point without syntax errors and with instant feedback. Visual abstract learning, where concepts such as loops and conditionals can be seen in a tangible and concrete way. Motivation through creativity. When students build something they truly like, their motivation to learn increases. A strong user community, a global community behind Scratch that is also a digitally ethical community where members support one another. For all these reasons, Scratch is incredibly effective and appealing for our children and beginners. But what are Scratch's limitations? Despite all the advantages we mentioned about Scratch, it's certainly not flawless. In fact, one of Scratch's drawbacks is its scalability. Scratch is not suitable for the following cases. For example, you can't implement complex data structures in Scratch, or you can't implement advanced algorithms using Scratch, and it is not suitable for large-scale software projects. Secondly, transitioning from Scratch to text-based programming languages is not very easy. It takes some time. Moving to languages like Python and Java requires learners to learn syntax, learn how to type accurately, and also get familiar with debugging or troubleshooting text-based programs. And lastly, there is the risk of overuse. If students work only with Scratch for too long, they might feel stuck or feel like they're not progressing. These are the main drawbacks that can be discussed regarding Scratch. With everything we've talked about and examined, the main question is this: is Scratch still worth learning today? For children and beginners, the answer is completely yes. For long-term goals, Scratch should be the starting point, a part of an educational journey, not the final destination. Of course, if it's used correctly, Scratch provides a solid foundation for learning the sciences and makes the path much easier for kids, helping them understand computer science concepts more easily. Without a doubt, Scratch will still be a suitable choice for our children. As a conclusion, we can say that Scratch is a programming language that was born in 2007 at the MIT Media Lab. It transformed the way programming is taught around the world, and today it has a very large global community. It has changed people's perspective on computer science and computational thinking, and has made access to computer science much easier for students and beginners. Despite its limitations and the competition from newer tools, Scratch still remains a powerful educational platform, and its main message is still valid. Programming is not only for experts. Anyone can learn it, create with it, and express their ideas through it. Thank you for staying with us until the end. Stay with us and keep following along. Thank you. Wishing you success.